Yes, now I think it's okay. So as we were discussing about the manufacturing process of PVC by casting. So as I've explained you earlier, in PVC by casting, we are using a special type of paper, which is we call it as a release paper. And this type of paper is having different patterns, grains, and finishes, which are being transferred onto synthetic leather. And in this, as I've explained you, this is an application, typical application, where first we apply a top layer onto the release paper, so that the space is having a compact layer, which is having PVC resin and plasticizer. So we are giving a gap on a coating machine to form that particular layer from a liquid paste. And to dry up that liquid paste, we are drying it into the oven at 120 degrees centigrade. And after drying, we are cooling it down. And then it is a continuous process. It is going to a second stage, which is second coating station, which is where we are applying a PVC foam layer. And after application of PVC foam layer, that is again going to a drying oven. Drying oven is very long, usually 20-25 meters long. And this is having a temperature of around 200 degrees centigrade. So at 200 degrees centigrade, this chemical blowing agent, ADCL, is coming into picture and making a foam layer into PVC. So we can have a foam structure to gain the thickness. Like when we need to make a different thicknesses like 0.8, 0.9, 1.2, according to the thickness required, we are giving the coating weight or coating GSM and expansion so that we can get a desired thickness, which is required into this application. And again, after foaming, we are cooling it, and then we are applying an adhesive layer. So this adhesive layer purpose is to hold PVC film as well as backing fabric, which can be a non-woven knitted fabric or different substrates. And after that, again, that is being dried at 200 degrees for final curing. And after this final curing, we are releasing this PVC leather cloth and the release paper. So release paper is voided separately, and finished PVC leather is voided separately. And then after that, inspection and many other processes are done to make small rolls, which can be shipped to the end user or the customer. So here you can see this is a typical line diagram for a coating machine. This is the release paper unwinding, this red portion. And this is the first coating session where we are applying a top coat. And this portion is a drying oven, wherein temperature something like 120 degrees centigrade is there. And this is a cooling section. We are cooling this coated release paper. And this is a second coating station wherein we are applying this PVC foam layer. So after this PVC foam layer, this is again a drying oven wherein temperature is about 200 degrees centigrade, then cooling station. And this is a third coating station. And again, this is the oven. And this is a fourth coating station where we are applying a adhesive layer. And this rolls you can see is a fabric unwinding. And here we are laminating different type of substrates, which are backing cloth of a synthetic leather. And this is a final curing oven. And after that, cooling is there. And from here, as you can see, we are separating it. This is a release paper, and this is a finished PVC leather, which is bounded. And from here in, it goes to inspection machine where we are making small rolls, 100 meters, 200 meters, and this goods are being shipped to the different users or vendors. And usually this PU dry process and PVC dry process is having a very similar process. And I will show you further processing of the second generation. Now, this process I'm explaining you is about the first generation of PU processing, wherein PU synthetic leather is made. Now, PVC, I'm hopeful I've explained everything. If you have any doubt, we can discuss.
Doubt session हम end में कर लेते हैं.
End में कर लेंगे. ठीक है, sure. So now this is a manufacturing process for PU synthetic leather. As I told you, is a first generation. And in this first generation of PU production, we have two processing machines. First machine, we call it as a wet process. Why this is called wet process? Because here, this coated PU resin is being entering into a solution of water and a DMF. DMF is a solvent, which is completely soluble in water. And this product, why this process is chosen and why this process is very close to leather. When we are doing this coagulation, the product which is made by coagulation has very unique properties of having a breathability. That means can absorb moisture just like a genuine leather. It can breathe, like air can pass through this layer, like from the top to the bottom. So the person who is wearing it will be having a highest level of comfort as genuine leather. And as this product is a synthetic product, so we can design this product according to the requirement of different applications. Like for shoe lining, we have a very high breathability. For garments, even more high breathability is possible. And for sport shoes or a men's shoes upper, it can be a waterproof and still breathable. That means the water cannot penetrate, but it can be still breathable. So that the wearer, usually if we are making a snow boot, he can feel the warmth of a genuine leather, and still the shoe is waterproof. The snow and water is not coming inside to the shoe to dampen the inside of the shoe or the garment. So here, as I explained to you, we have a fabric unwinding, and this is PU dipping and coating. So here we have a PU solution, which is having a PU resin as well as some solvent like DMF. We are dipping into that bath to the fabric, and after dipping, that coated substrate is going to a coagulation bath where this poromnic structure is formed. And after this coagulation, we need to remove all the solvents and different chemicals. So we are doing a washing of the synthetic leather that is breathable. So during our washing process, all the solvents and everything is extracted into these tanks, and water is only remaining into the synthetic leather. After washing, that is being dried into a drying oven at 150 degrees centigrade. And after drying, we are winding it. So till this process, as it is indicating, it is an intermediate PU base, which needs a further processing. Till this stage, there is no texture, no finish, nothing on this. This is only a sort of a foam layer or a poromnic layer, which you can say, which is being formed onto any sort of substrate. So in the second process, we called it as a dry process. As this process explained, it is having a similar processing like a PVC. Here we are using a release paper. So all release paper are similar of silicon coated type, which is having a different texture and finishes, which will be transferred onto this base. So after this release paper unwinding, we are applying a PU top coat. Here, instead of PVC polymer, we are using a polyurethane as a polymer, and the coating process is exactly similar. And after applying this top coat, we are drying it at 120 degrees centigrade, again cooling it, and then we are applying a PU adhesive. So this adhesive layer is against, instead of PVC, we are using a polyurethane adhesive. And after this PU adhesive, we are laminating this intermediate base. So this intermediate base, when we are producing a wet process, can have a different structure of fabrics like knitted, woven, non-woven, depending on the product, as similar in case of PVC. After this lamination, again, we are drying it at 120 degrees centigrade. And after drying, similarly as in PVC, we are releasing it from the release paper. So the release surface is a PU synthetic leather, and paper is again rewinded. And this paper is used like 10 to 12 times repeatedly to get cost effectiveness from this paper. And very similarly, after rewinding, small rolls are cut and being shipped to the customer. So this is a common layground. This is a more dynamic sort of background you can see. So this is unwinding of the release paper, storage device for release paper. This is a first coating station. After that, this is a drying oven, and this is a cooling station. And here again, a second coating station where we are applying this PU adhesive. And this intermediate is a PU base, which is coming from a wet process. And after laminating, again, we are drying it and cooling it. And after cooling, you can see this is separation. This light beige product is a PU synthetic leather, which is being wounded. And this dark brown is a release paper, which is again coming back here for a second production. And we are coming to the next chart. This next chart is wherein all these products are used, like markets and application. Typically, PVC synthetic leather, which is produced by coloring, is main market is automotive seats, backpack and luggage, and leather and sports goods. So as I've told, automotive seats, like in case of a seat for car, or even the side trims or the doors of the car, usually these are having a PVC film. So coloring product is mainly used into that application. And backpacks, as I've told you, those are polyester Tretton fabrics. Inside, we are coating with PVC to make it waterproof and more durable and fray-free and something like that. And leather and sports goods, some applications, yes, we are able to make certain hard bags. If we need to make a very hard bag or a rigid bag, that will be possible only with the coloring process. With casting, it is not possible because usually casting products are more soft and supple, and we cannot produce very hard products from a casting machine. And this casting process is automotive seats. Automotive seats like this sitting area is mainly produced by casting process because there is more soft and more tactile, having more grain finishes and much more closer to genuine leather. And footwear and shoe lining, like for chappal uppers and shoe lining for chappals, and upholstery also, like similarly house furnishing and chairs of the office, everything. And some garments also, like jackets are for low end, people are making in PVC. And certain type of backpacks as a decoration pieces or small piece goods, we are also making from casting process PVC leather. And also for sports goods, like for some hand gloves or even the batting gloves or pads and many other applications. Like these are the pictures, some of the pictures you can see, which are made out of it. I'm sorry. And this is PU synthetic leather. And PU synthetic leather, PU based from dry process, is used for footwear, shoe lining, backpacks, handbags, leather, and sports shoes. Majorly in Indian market or international market, uh, PU is more widely used for ladies' handbag, high fashion handbags, because these handbags are very light in weight. As I've told you, PU is usually very light, and shoes like leather shoes, formal shoes, as a molding property and everything is very close to genuine leather. So if you make a shoe out of PU, so sometimes for a common man, it's very difficult to differentiate if that is made of a genuine leather or a PU synthetic leather. And similarly for garments, in garments, we need a very thin quality and very soft and stretchable. So those products are possible only in polyurethane, because polyurethane is having very high elasticity, and we can design it in such a way it can have up to 400% of elasticity, which is needed in garments, like when we're bending our hands or our body movements are there. So that is possible only with polyurethane. In case of PVC, usually that is not possible. PVC is having a very thick layer and PU is having a very thin layer and very high elasticity. And now we are talking about the second generation of synthetic leather, as we are moving towards more environment friendly products, wherein we will having a very low VOC or a very less use of the solvents. So in this product, like the mainly right now, which we are successful nationally as well as internationally, is for furniture and automotive products only, and certain products for ladies handbag and shoe lining, but not all type of products like formal shoes upper or leather goods are not very much made with the second generation of polyurethane. We have a limitations till now. So in this here, and this second generation of PU solution of synthetic leather is having zero organic solvents. Like as I've told you, in our previous process, we are using a DMF, which is a highly volatile organic solvent. As we are recycling that solvent, but still some amount of solvent is used and which is being evaporated during, or losses are there into the atmosphere, which is causing certain amount of pollution worldwide. So to avoid that, we are not using this any sort of organic solvent is this new technology. This technology that's we have named it as a green tech, that is a green technology. So this green technology in a polyurethane system of synthetic leather, which does not use any organic solvent. So it is a unique combination of performance as well as environment friendly. So this product meets very high VOC norms. And this process, as we are omitting this wet process from this processing field, so this process is more simplified. We are using only a dry process application or dry process coating machine into this, and superior properties like with this product which we are making is having high life of like 8 to 10 years before it is getting hydrolyzed. But a normal PU which we are producing for wet PU is maximum having 3 to 4 years of life cycle. So now with this new technology, we can have a polyurethane which can have a life of 8 to 10 years or even more in terms of uses. So this is an application overview. So here with this product, as we said, it's a low VOC, softness is good, good stitching is there. We can achieve a very high resistance of flame retardancy, which is needed for some, as I've told you, application in upholstery, car upholstery and home furnishing, and good UV resistance. And as these products are solvent-free and environmental leather, so certain buyers in Europe is using it for footwear, for shoe lining, and backpacks and handbags also. And that's it for this. Thank you. So
Very
any
nice.
questions or any queries?
Students, you may ask question to sir. So you must have noted down so many things. So we ask you to ask questions to sir.
Sir, I have a doubt.
Yes.
Sir, what kind of material is used for lamination?
What sort of lamination?
Sir, in PVC calendaring.
Lamination is a process, intermediate process. Like as I've told you, initially we are making a PVC film by coloring. That PVC film is a plastic sheet. That plastic sheet is laminated to different substrates. So substrate can be a woven fabric, knitted fabric, non-woven fabric, depending upon the end application. Like for a bag or a luggage bag usually have a polyester fabric. So that polyester fabric will be laminated to this PVC film. And then that finished product or a commodity will be used for the application of a luggage bags or a hard bags or different application. And similarly, if we are using any handbag or a stretchable product, so we will be laminating some knitted fabric into the backing of that.
Sir, also why in calendaring process there is no foam layer, but in the casting process there's a foam layer?
That is a process limitation. We can have a foam layer into a clinic process also, but that is a more complicated and not cost effective. So that's why people are usually not using any sort of a foam layer into a clinic PVC leather.
Okay, sir. And also, like, what is the difference in automobile seats when you compare the processes?
In automobile seats, in automobile seat, as when we are sitting, usually the place where we are sitting, we need some sort of cushion and a soft effect. So usually anything which is having a soft effect will be having a foaming layer or a foam layer. And the product which is made by casting process is more softer as compared to a calendric process. In calendric process, we are melting the polymer and making a film. So usually the product which is made by calendar is having more plastic finish and more rigid finish. And the textures and everything which we are casting are not as good as which are being made by casting. In casting, actually, the release paper is acting like a mold. So we can have a very soft touch, and the grain depth and the grain retention is much higher and much nicer to touch on the top as compared to coloring process. So that's the reason mainly for the sitting application, all the products are used which are made from a casting process only.
Yes, sir. So in calendaring, we use it only to like on the sides of the seats.
Yeah, like you can say it's for luggage and in the car door trims. If you're sitting in a car, the area where we're sitting is having a little soft finish, whereas on the door trims, you can feel a plasticky finish. So
Yes.
that is more of a PVC calendar film application.
Okay.
Any other question, students, please? You may ask to sir.
Sir, I would like to ask that vegan leather made up of mango pulp and new things which are going on today, will it be suitable for making upholstery and heavy duty leather things?
No. Till now, what they have done out of that leather is some complementary goods like small pocket wallets or non-performing articles only. Till now, for a upholstery application and high performance application, definitely not. And the another reason why that is not possible to use it, usually this car policy, if you are buying a car or a place for a public places, the product life should be at least like 8 to 10 years or more, so that we can get a serviceability of that time. And if we used to have that product should be free from any sort of bacteria or antimicrobials and many other things which can degrade and which can cause many other side effects, which are not possible in a product like vegan leather, which are made of this product. So vegan leather is having a very short life, like 2 years or 3 years. After that, that will start to decompose. So if anything in a car which is used, which is decomposing after 2 years, that can be like a nightmare or a person who is using it. So that's the reason until now vegan leather is not used to that application. It is just used for us fashion goods where the life cycle is maximum 1 to 2 years only right now.
Okay, sir. Thank you.
My pleasure.
Sir,
Also,
nowadays,
I wanted to ask,
yes.
sir,
Please
I
tell me.
wanted to ask, in this PU synthetic leather, since even
Yeah.
though we have some amount of plastic, how is it flame retardant?
We add certain chemicals, phosphates and halogens, which doesn't support oxygen. Like when we are burning it, they produce carbon dioxide. So once carbon dioxide is present, so the product which is produced will be flame retardant.
But then if it is repelling oxygen, it will not be breathable to the skin, right?
No. Breathability is coming from the type of structure, polymeric structure, which we are making. So the structure, the cell shape which you are making is an open cell. So when the cell structure is an open cell structure, we can achieve a breathability. And in case of PVC, the cell structure or the foam layer which we are producing is having a closed cells. So due to that closed cells, we don't have a breathability. These are two different aspects actually.
Any other student?
May I?
Yeah.
May I?
Please.
First of all, good morning, sir, from all of us. And my question is that we all know that luxury items have its another race, and also the eco-friendly items have its another race. So what we see in the future, is it eco-friendly or luxurious and the fuse of the both?
Like I see in future, that will be a combination of a eco-friendly as well as luxurious articles. So there are only sustainable products. Definitely every day we are evolving and newer technologies coming up. And as the people are getting educated, our society are getting educated. So definitely with that time, we need to improvise and have a new products. So I see for the future, definitely we will have a more eco-friendly products, more environment-friendly products, and sustainable products, definitely. So that is the future.
Thank you so much, sir.
Sir, one thing I just wanted to know that in case of polyurethane, can we generate more breathability? Can we generate more pores, or because of the structure?
Yes, exactly. As I've told, when we are making a film, the foam layer, so depending on the end product requirement, we can alter the type of foam cell layer which are forming, and that can alter the amount of breathability. Definitely, yes. So we can make a very high breathable product. Like even just as I've told you, we are making certain products which are used for skiing. When a person is wearing a skiing garments, so that should be very high breathable and waterproof. The reason why it is a high breathable, because that person who is doing a skiing, it's a minus temperature outside, and inside due to warmth, he is sweating also sometimes. So if that sweat is not dissipating, the person is not feeling comfortable at that atmosphere. So we have a polymers which we design so that can absorb all the sweat, and that can transmit or to the atmosphere. So the person who is wearing it will be more comfortable and wearing it for long hours. Even like today's, you can see this PPE kits, which are being made here in India for the doctors and everything, which are very popular. If a proper PPE kit, which is used worldwide, should be having a polyurethane coating inside, which is moisture absorbent and waterproof. Because that, what will that happen when we are sweating? That sweating moisture will be absorbed as PU film, and it will be constantly transmitted to the atmosphere. So the wearer can wear it for 8 to 10 hours. But now here, that's our pity. We try to push this product to Indian government, but due to price constraints and everything, people don't want to use that high performance product. So they are using a regular low profile products, wherein the product is not breathable or moisture absorbent and give us the comfort.
Very nice. Thank you, sir.
My pleasure.
Sir, one more thing, that when you completely eliminate solvents and when you use water-based, the processing system will also be changed because of the evaporation, and you have to dry it properly.
Of course. Actually, you say 3 years back, people are more moving towards water-based system. So now water-based are used just for surface finishing mainly, and the middle foam layer or the performance layer is made with a non-solvent products. So now it is a combination of non-solvent and a water-based product. So in non-solvent product, it's a 100% system, that is a reactive system, where we are using 100% active integrants to react onto the paper itself and doing the coating. That's a very special technology and very new technology right now.
Yeah, non-solvents. I have also not much aware about non-solvents here. Either we were using solvents or water, but non-solvents are.
Yeah, again, water is a solvent and water is also having scarcity. So we cannot shift 100% to water-based system also.
100%. Yes, you are right. It's not feasible. Absolutely.
Yeah.
Students, any other question if you have?
I think we are overwhelmed with so much of input from Mr.
Yes.
My pleasure.
Everyone is like so overwhelmed with so many input. They are like absolutely quiet now. They are just absorbing everything. I just wrote it down.
So if you like,
message them, please note down all the things. Because even I am doing the same thing. Something we are.
No issues. I can share this presentation to you if you want. I can email this presentation to you, and you can keep it as a record. And in case you have any query, anytime you can email me for the queries, and I can answer.
Thing. Presentation is one thing when you speak about your knowledge comes out in your knowledge and experience, everything. The combination, presentation doesn't is in itself is not enough. When you have a someone who is so knowledgeable out there, so input from you, that is more important. So I have been noting it down. I want my students to do the same. So once things get normal, I would like my students to come out there. Noida ka to
sure. My pleasure. Anytime.
Students, you want to ask something? Because you want to ask something? I think.
Sir, thank you very much. And we are really very grateful to you, myself and FDDI family. And we really enjoyed your session, and you could spare time, and we are really very much thankful to you, sir.
That's my pleasure, Madhur Sahab. And I know when we are sharing our knowledge, we are increasing our knowledge. So that's my principle.
Yes. And we will be troubling you continuously years after years.
My pleasure. Anytime.
Yes. Thank you so much, sir, for being here.
Thank you.
Thank you, Madhur sir.
Thank you. Thank you, Aarti ma'am.
Bye.
Thank you.
Bye.
Bye-bye. Bye-bye.